Ever since I started shooting video and started digging into the fundamentals of all of this stuff, one question has sort of perplexed me for, well, basically ever since I started. And the question is, just how much dynamic range can be stored in a BT709 file? I mean, obviously we've moved on to 2020 and now 2100 and the wider dynamic range HDR stuff, but in the original BT709 format, which incidentally is what I shoot all of these videos in, just how much dynamic range is there? So I downloaded a copy of the BT709 standard from the International Telecommunication Union. This is not the whole standard here. The whole standard is quite long, but there are 2 pages in the standard that we need to look at. First is page 3, and page 3 gives us the overall opto-electric transfer characteristics for our camera, or for how things are going to be converted. So this tells us for a scene luminance level that's normalized between 0 and 1, what is the digital value that's going to be output from that? Again, normalized between 0 and 1. The other page that we need to look at is page 5. And page 5 gives us the broadcast legal coding points for black and white. So we're looking at 8-bit, although because both 8 and 10-bit are normalized to the same 0 to 1 range for this, the ranges will be the same. 10 bits will give you more precision inside of that range, but the black level is defined as being encoded as a value of 16 out of 255. So luminance, black level, 16. In fact, it applies to all of the RGB values. Peak is going to be the brightest white, or the white point. For luminance, because we're not looking at color here, 235 is the maximum value that can be. So we need to do a little bit of math, and this is why I said I found answers. Some of them are a bit conflicting, some are certainly rounded, but I wanted to do an answer and share the math. So the first thing we need to do is rewrite or reorganize these transfer functions into their inverses, essentially. So we need to solve for luminance instead of voltage. So for the first one, we're going to have, and I'm going to just speed through the math here so that we aren't all bored. And we will, in fact, need to use both of these formulas for this. So the second one is, so for the minimum, we are going to plug in the minimum black point, 16, and this has to be normalized between 0 and 1 based on the 8-bit coding. So we're going to make the adjustments for that, and we're going to solve this. And we'll just round it off there. So max, for the maximum, we're going to do the same thing. We're going to plug in the white point, or the maximum value, the peak value of 235. Again, normalizing it between 0 and 255, because that's what an 8-bit number has to be normalized to, and then convert the number, and we get this result. So that gives us our minimum and maximum luminance levels, again, in a normalized range. So now we just have to convert this to figure out dynamic range. Dynamic range is just the maximum divided by the minimum. And we'll just round that to 60.84. Now that's not in stops. That is just the dynamic range as a linear number. So to convert that to stops, we take the log base 2 of it, and we'll just call that 5.93. So 5.93 stops. That is the extent of what can be stored dynamic range-wise from brightest to darkest in a Rec.709 broadcast legal format file. Of course, the next question is, well, what about if it's full range? Since most of our cameras shoot in full range, the camera companies have decided to sort of throw this broadcast legal stuff out the window. Just how much range are we losing for not having full range? So in this case, the maximum is going to be the minimum is going to be, signal is going to be 1, and the maximum signal is going to be 255. We use the same formulas. So this would be 1 divided by 255 divided by 4.5. We'll just round that off to that. And the max is going to be 1, obviously. And so if we actually do this equation here, well, 1 plus 0.099 divided by 1.099 to the 1 over 0.45 is obviously going to equal 1, because that over that is 1. Raised to any power is going to end up being 1. So we have a dynamic range of 1 divided by of 1147 point, we'll call it 4. So converting that into stops, we'll just call it 10.2 stops. In the first video in this series, I talked about how there is a lot of baggage in video formats and processing, and goes back all the way to the analog era when information had to be encoded outside of the displayed space. And as video has progressively moved forward into digital and into higher end digitals, sometimes that baggage gets carried along. This is a perfect example of the baggage that we are seeing, or the impact of that baggage. A broadcast legal Rec.709 file can only contain 5.92, or let's just say just under 6 stops worth of dynamic range. However, if we use the entire amount of data that can be encoded in an 8-bit number efficiently, the way we should be using it, we can get 10.2 stops without having to make the file or the coding any larger. We don't need more bits to store that information. That said, I hope you found this useful, or at least interesting. If you did, let me know by hitting that like button. Also, if this kind of thing seems like it might be your kind of thing, please consider subscribing if you haven't already. Finally, if you'd like to help and support this channel, you can help us for free by liking this video, sharing it with your friends, and leaving a comment with your experiences. Likewise, you can support us by hitting that thanks button or buying yourself something you've always wanted from one of the affiliate links in the description below. And as always, thanks for watching, and I'll see you next time.